Here we have a motion problem. How long will it take a bus traveling at 60 miles per hour to overtake a car traveling at 40 miles per hour if the car had a 1.5-hour head start? And with motion problems, there's really only one equation that you need for starters, and it's this one. Rate times time equals distance, or you could think of it as distance equals rate times time. All right, and sometimes you need another one, which is this. Basically, you're just solving for time, right? So you might need this. Time equals distance over rate. And there I'm just dividing by rate. Okay, so use that equation, and when you see a rate and time problem or a motion problem like this, you can put everything into a table. And I recommend using the table for these kinds of questions. Right? There's all kinds of word problems in intermediate algebra, and a lot of them require this table, or a table of some kind. And if there were an easier way, I'd recommend using the easier way. But the table, I would say, probably is the easiest way. So just get used to using these tables. It really helps to organize the information and put everything together. So let's see how that goes. Okay, here's a table over here. Okay, so it goes like this, right? You do a table out like this, and it's rate times time equals distance. So you can even put rate times time equals distance into your table. Okay, and you kind of set it up like this and fill it in as you go. Okay, so let's fill in what we have. We have a bus and a car. Bus and car. Okay. Oh, and it gives us the rate, right? Rate, you can think of rate and speed. Those are the same thing. Okay, 60 miles per hour is the bus going. Okay, 60 miles per hour. And it's overtaking a car, which is traveling slower, 40 miles per hour, but it had a 1.5-hour head start. Okay, when a problem's asked how long, that usually means that time is the unknown. So I'll say this. That usually means that we're solving for time. Okay, when you see the words how long, it's usually an indicator of that. Okay, so let's see here. So if the bus has been traveling t, let's say that t time, the car had a 1.5-hour head start. So the car has been traveling the same amount of time as the bus plus 1.5 hours. Okay, so when you have a head start, that means you've been traveling for longer. All right, well, rate times time equals distance, so now we just multiply these across in our table. 60t and 40 times t plus 1.5. Okay. Now, when they say overtake, okay, this word overtake here, right, that means that the bus has caught up with the car. The bus that is traveling faster has caught up with the car that is traveling slower. And at that moment, when the bus passes the car, the distances are equal. The distances are the same. So I'll say distances are equal. Okay, can you imagine that, right? Imagine a bus. They started out, it finally is passing the car right at that moment. The distances that they have traveled are equal. So this means that we take this distance here and set it equal to this distance down here. So we have 60t equals 40, and then t plus 1.5. And now we are done with the table, right? Now we've lined up all our information, and we have an equation that we can solve. And I would argue that it's really hard to go straight from the word problem to this step here. It's possible, and you're more than welcome to do it if you are so inclined and have those skills. But really, especially when we start doing, mixture problems and all these other kinds of problems that require tables, it might just be best to get used to using the table. Just use the table, get the problems done, and it's not so bad. Okay, let's solve this thing for t. 60t equals 40t. I'm distributing here. 40 times 1.5, so this is 40t, plus 40 times 1.5 is 60. All right, solving for t, let's see, so 20t equals 60, dividing by 20 gives us t equals 3. And let's see, now at the end of these problems, you don't just stop, right? You have to make sure that we've solved the problem and that we've answered what the original word problem is asking for. So how long will it take the bus traveling 60 miles per hour? Okay, so here we let the t be the speed of the bus. It's actually best practice to write that. Let t be the speed of the bus. Okay, just to keep everything cool, we'll write that out. Okay, so then when we've solved for it, we have t equals 3 hours. Well, that's what we're trying to, how long will it take the bus? We have our variable set up for the time that the bus has been traveling, so t equals 3, and then don't forget your hours, your units. In this case, it's hours, 3 hours.